Hello, this is a demo for our elastic load balancer. As you can see here, we're in the Horizon dashboard. I'm going to show you the current setup right now. We're in demo project. There's already a load balancer created named ELB. It has a VIP of 20.0.0.12, one listener. It's using round robin, one pool, and then we're going to show the backend members that are attached to this load balancer. So the backend members are red node 1, red node 2, and red node 3. With its respective IP addresses, 11.0.0.8.9.10. So these guys are simple web servers that will show a flower shop, each one displaying a different red flower and their respective IP addresses. Up here is the stressor. This is nothing but an instance that will simulate heavy traffic for our load balancer. This will be used later when we try to scale up and scale down. Alright, let's leave the demo project and go to admin. We're going to show the M4Is. You can see here that there are two M4Is for this load balancer. Let's note these few characters, LMP and P56. We'll see those again in a little bit. So right now there's two load balancers for this one, two M4Is for this one load balancer, and this will be working together active-active. It can scale up to 4 load balancer, which is the max. 2 is the min right now, and this is only for this demo purpose. And down here you can see a distributor. This guy will get the requests when we curl the VIP, and it will distribute to the backend M4Is. Alright, so now we're going to take a look at the backend, the web page. So this right here is the VIP. It's been assigned a floating IP, so I can access it publicly. And that floating IP is masked right now, just for security reasons. On the top here, you can see the IP address of the backend member, the flower in which is being displayed by the backend member, and which M4A is responding to the request. I'm going to refresh the page, and let's see if we can get another M4A to respond. Alright, so right now we have P56. Let's refresh the page again. Still P56, but as you notice, it was 11.0.8. Now it's 11.0.0.9. It's the same M4 again because of the hashing algorithm we're using. Let's try refreshing again. Okay, still P56. 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 Alright, so now we're getting a response for a different M4A, LMP. Okay, let's simulate the scaling up. So to our stressor, we're going to start the stressor, and this will send pings to the VIP to increase the CPU usage of the M4Is. Okay, over here is a logger. We can see this is grabbing the centimeter alarm logs of the percentage on each M4I. So these are the two M4Is, and they're only at 3%. So the scaling threshold right now, scaling up threshold, is 40%. Once these guys pass 40%, it will alarm, and heat will spawn another M4A to help with the CPU usage. So this will take a couple minutes. You can already see that it's scaling up. It was at 4%, now it's going up to 11 and 19 right here. We'll take a few minutes to wait for this to scale up. In the meantime, I'll show you the alarm. So we do accelerometer alarm list. We can see that our alarm, our scale up policy at 40% is alarmed now. Let's go back to that logger. It is at 55 and 50. Looks like our control worker is starting up. Let's go back to the horizon and take a look. As you can see right there, an amphora is being spawned. It's not yet plugged yet, but it is responding to the CPU usage already. So let's wait for this to complete and scale up to 4 amphoras, and 4 eyes. You can see that now there are 4 total M4 eyes. However, they're not fully plugged yet, so let's wait a couple more minutes. Okay, so it looks like we now have 4 M4 eyes fully spawned and all plugged already. We're going to go back to our flower shop and let's see if we can crawl from not every single one, but let's see if we can get the requests from the new ones at least. Alright, we got one EKX from this newly spawned M4 right here. Let's keep going. EKX again. This might take several tries due to our hashing algorithm. Okay, we got P56, which is our first one from earlier. OQB, which is one of our newer ones. Yeah, so you see here that we're getting requests from multiple M4Is at the same time. Back to IMP, or LMP, sorry about that. Alright, so now I'm going to stop the stressor, and this will bring down the CPU usage and scale down the cluster of M4Is. So this again will take a few minutes as well. You can still see they're pretty high still, upper 40s. And you can see there's still 4 M4Is serving as one load balancer. Let's just give it a few minutes. Okay, so you can see that it is dropping down. Let's take a look at our centimeter alarm. Okay, they're both okay now because they're in between the scaling up and scaling down policies. It should trigger that policy soon for scaling down. Still has a little bit to go. Okay, awesome. So everything is below 10% now. If you go back to our alarm, we're going to see that our scale down policy is alarmed now. So anything below 10% will scale down our cluster. So this will trigger heat to take down our extra M4Is until we reach the minimum of 2 M4Is. Okay, as you can see, 1 M4 has been deleted from the cluster. There's only 3 M4Is left. It's going to keep scaling down until there's only 2 left. And you just saw right there, another M4 was deleted, and now we only have 2 M4Is left, and that's the minimum. And then we should be able to go back over to the flower shop and request a refresh from the flower shop, and we should get only responses from those 2 M4Is. OQB, EKX. Alright, thank you for watching this demo.